Welcome to lesson 7132, modeling periodic behavior with sinusoids. So now, take a look at this. This is what we're going to be using to do periodic behavior. Anything that cycles, springs going back and forth, rising and falling tides, Ferris wheels, any kind of cycles with the human body, any kind of cycles can be modeled with the sine and the cosine because they go back and forth between 1 and -1. So we are going to use all of these formulas. The amplitude, to figure out the amplitude, the vertical shift, what adds or subtracts to the angle, the period, the number that multiplies to the angle, and here go our 4 equations that we use. Depending on the information we're given, we'll use one of them. So we know that the sine starts at 0 and goes up and comes down. If the cycle, so the regular sine goes up and comes down, that's a regular sine wave. Negative sine wave, it goes down and comes up, so it depends on what the motion is doing. The positive cosine starts high, goes low, and ends high. The negative cosine starts low, goes high, and ends low. So depending on what the model is doing will determine which of these ones we use. And we saw this in a previous example. So let's look at example of cyclical motion. Okay, so let's look at our next example here. Calculating the ebb and flow of tides. Tides work on cyclical motion, which can be modeled sinusoidally with sinusoids. So on July 4th, Galveston, Texas, high tide occurred at 9:36 a.m. This is a time which lets us know that time is our input. The West Street Pier was 2.7 meters deep. All right, so now we got to have a height. This is our Y. Low tide occurred at 3:48 p.m. This is a time, and it was only 2.1 meters deep. Okay, assume that the depth of the water is a sinusoidal function with a period. So now we have a period here, a period of 12 hours, 24 minutes. The first thing we're going to do is we're going to do some conversions with the time. We're going to figure out the amplitude. We're going to figure out the period. So we're going to do all of that now. Then we're going to set the window on the calculator, and we're going to use that to help us analyze the graph. So the first thing we want to do is look at our time. So we have 9:36. Was high tide. And then we take our 36 and we multiply it by 1/60. And that is going to give us, 0.6. We're going to take 3:48 p.m. And all times, we got to realize all times start from midnight, which is 0-100 hours. So 3:48 p.m. is actually 3 hours after 12 p.m., which is 15:48. And then we do 48 divided by 60 to get that fraction of time, which is 0.8. So we got 9.6 is high tide, 15.8 is low tide, and then 12:24 is our period. So 24 divided by 60 equals 0.4. So 12.4 is our period. Okay, so now we got a high at 2.7, our low. All right, so our high tide occurred at 2.7 meters. Our low was 2.1 meters. So it's not that much of a difference between high and low tide. So now we analyzed all of our information. We have time as our input, which is going to go on to X, and depth is going to go on our Y. Now we want to know at what time on the 4th of July did low tide first occur. So since we're starting at 9.6 hours in at a high, and so 9 to 3 is 12. Roughly 6 hours later, we're at our low point. And we're starting high, we're ending low. It's going to be a sinusoid. So it's going to do something like that. I think we're going to pick the cosine function because we're starting with the high. We're not starting at 0. We're starting at a high or a low, so we pick the cosine function. So this is all the things you have to do when you solve a problem like this. Before we even start to look at the problems, this is what we have to do. Okay, so from the previous page, we have our numbers. So 9:36 a.m. is 9.6. This is 9.6 hours from midnight. 3:48 is 15.8 hours from midnight. Our 2.7 to 2.1 is meters. 9.6 and 15.8 are times. Our period equals 12.4. This is our period, our B. Now we got to calculate A, B, C, and D. We got to calculate A, B, C, and D. So let's start with A, our amplitude. To get the amplitude, we take the difference between a high and a low, divided by 2, which gives us 0.6 over 2, which gives us 0.3. So this is our amplitude. To get our phase shift, our D, we take the high plus the low, divided by 2, and that will give us 4.8 over 2, which gives us 2.4. Our C is 9.6. So our C, why does our C equal 9.6? Because from midnight, that's the time when we have our high tide. And then our B. So the new period equals the original period divided by the B, which is 12.4. Reduce your fractions. You shouldn't have decimals in a fraction, but since pi is not a real number, is an irrational number. It is a real number, it's irrational. Since pi is irrational, we're going to leave a decimal in the denominator. So we got A, we got B, we got C, and we got D. Now we can write our equation. So using the numbers from the previous page, our equation, depth as a function of time, is equal to our A, 0.3. We use the cosine function because we started with a high tide. Our B is pi over 6.2. The time minus 9.6 because it's a rightward shift. The high tide occurred at 9.6, but minus for the right shift, and then plus 2.4. We didn't even start solving a problem. We didn't even do A, B, or C yet. This was all, we had to do all this just to write the equation. Now we have the function, you put that in the y equals. We're going to use the graph to analyze the function so that we can answer the questions. So what we're going to do now is hit window. Hit the window button. It's in the top row of buttons, and I should have probably put this in white because the window is white. So now let's look at our X-min and our X-max. X-min, if 0 is midnight, you probably want to go to 0 or -1. X-max, for a full 24-hour period, I would probably go to 24 or 25. X scale, let's start with 1. Let's look and see what the graph looks like. We might have to revisit this one. Okay, so for our Y-min is at 2.1, so maybe I will make my Y-min 2, and then my Y-max, it hits 2.7, so I'll make it over so I can see the whole graph. I will make it 2.8. I'll leave the Y scale alone, and then hit the graph button, see what you get. And if we don't see everything we want to see, let's adjust the scale from there. And so what my X scale of 1 shows me is every 1 hour. I've got my graph up, and I can see that my first low occurs a little bit past 3. It's around 3 a.m. because remember, 0 to y-axis is midnight. My graph goes a little bit left of midnight. So let me show you what my graph looks like. And this is what you should see in your viewing window. So we got 24 tick marks here. Your left line is actually a little shorter. So it comes down, it goes back up, it comes down, it goes back up, and it comes down. So you get almost 2 waves out of this. And maybe 2 full waves out of this. So our first low tide is right there. It's a little bit after the 3rd hash mark. How can we analyze that one? Okay, so my X scale was 1, but I see that my Y values do not go down to 2.1. So what I'm going to do is change my X scale. Now what this is going to do is create more tick marks on a graph, and I may not be able to see it. But if I change my X scale down, I go back to Windows, and I scroll down to X scale, and I change this down to 0.1, because 1/10 times 60 minutes equals 6 minutes. So 1/10 of an hour is 6 minutes. Okay, so now that I got every 6 minutes, I can get it more accurate. And then when I go hit the blue button second, and then I hit graph, this will bring me up the table of values. And I have to scroll down all the way out to 3.4 to get, when the X is 3.4, when X is 3.4, the Y is 2.1. So that tells me that's my first low tide. So now all I got to do is take 3.4, take the 0.4, multiply by 60, and that will give me 24. So that tells me my first low tide occurred at 3:24 a.m. So that's for question A. Okay, now that we have our window set up and everything in, so let's look at B. B, what is the approximate depth of water at 6 a.m.? 6 a.m. is 6 hours away from midnight. So when I scroll down, when X is 6, all I gotta do is just scroll down. Y is 2.3248, which is about 2.3. Because our meters are in tenths, we'll just round it off to tenths for the answer. Or you could go one more. Go one more than what they give you. Okay, so now at 3 p.m., it's 3 hours past noon plus 12 hours from midnight to noon plus 3 is 15 hours. So 15, or 3 p.m. is 15 hours from midnight. And that's why I need 15. So I'm going to scroll on my calculator all the way down to 15. When x is 15, y equals 2.1243. Y equals 2.1243. We're going to say that's about 2.12 meters. And don't forget the meters. Okay, so that's B. And then finally, for question C, what was the first time on July 4th where the water was 2.4 meters deep? So now, what I do, and this is a calculator trick, I'm going to hit second window. This is your table set page. When you hit second window, the first thing you see is table start. Change that to 0. Delta table, because you changed your X scale, is going to be 0.1. Leave that alone. Leave that at 0.1. We're getting every 6 minutes. So it takes a long time to get through 24 hours if you're going every 6 minutes. All right, so leave that at 0. Then hit second graph to bring you back to the table of values. And once you hit second graph, you will see that the table at the top is 0. At midnight, the water was 2.4454 meters deep. And we want to know when it was exactly 2.4. So scroll down and we see 0.3. When x is 0.3, which is our time, y is 2.4. I didn't mean write equals. X, y is 2.4 meters. So time is our input. We'll put T for time. So now, what is 0.3? So we're going to do 0.3 times 60 will give us 18. So that's 18 minutes. So the first time the water was 2.4 meters deep was 12:18 a.m. And once you set your equation up, you put everything into the calculator and just read the table of values. Yes, it's kind of difficult. It requires a lot of thought, but this is the easiest way to do it because it would be a lot of calculating back and forth if you wanted to do all of that. Do it the other way, where you put in the 2.4 and solve for the time and all of that. That's a lot of back and forth, and it leads to errors. So set up your calculator, do it this way. It's the easiest way to do it. So now go solve some problems.